So let's pull up our handy dandy calculator. And we'll type in second bars. Get it to you in a minute, Dana. Oh boy. Binomial PDF. And type in n. What is n? 7, comma. Huh? 0.65. And the last one? 5. Close parentheses and your 2985. Excuse me. 0.299. Huh? I thought it was round to the. Now I'm going to start sneezing. Okay. Yeah, 298. Okay, I rounded it up. I'm sorry. So it'll be 298. Yeah. N, P, and X. Yeah, we covered that. You came in late. I'm kidding. I done forgot what it said. 298. There we go. Next. Oh, look at there. They put them right back to back. Thank you. Not supposed to do that. N, P, and X. 20, 23.15, and 3. So you take your handy dandy calculator. All right. Save yourself some time. Second. And hit the negative symbol. Hit it again. I'm sorry. I'm stupid. Second, enter. 23. Dang old hit. Second, insert. Dang old 20. And I think it'll knock itself off. No, it won't. Just delete. And 0.15. Got a low probability here. And 3. And enter. 0.232. Let me rephrase that. Now everybody should make a 50 on the test. Because those two questions, unless you round wrong like I just did on the first one. Next question. Donald Duck. Alright. It says assume that a procedure yields a binomial distribution with n is equal to 5 and a probability of success of 0.2. Use a binomial probability table to find the probability that the number of successes is 3. Now you can do this two different ways. What are the ways you can do it? By the table, Hubert. That's right, class. And with the calculator. Thank you, Mr. Vaughn. Okay, two ways to do it. So I don't care which way you do it. I'm going to click on the table, no coughing. And let's look up n is equal to 5. Dang old, just follow n. Dadgummit, stop it. N is equal to 5, dang old right here. And look up your dang old point, what was it, point 2. Here's your dang old. Okay. Follow the point 20 down to n is equal to, or x is equal to 3. I'm trying. It won't let me. Alright. So, dang old point 2 goes down to, I can't remember my daggone numbers, 5 and 3. The help of this thing would work right. 5 and 3. I got 0.051. Is that what y'all got? Now let's do it on the handy dandy calculator. Second entry 5. Delete. What was the 0.2? And what? 3? 0.051. And we feel good about ourselves. Where is all of Hubert's homework and tests done? In the kitchen. Oh my gosh, I can't believe I made this test this easy. I think I need to go back and change it. Huh? It's perfect. Somebody will fail it. Anybody want to bet money on it? N, P, and X. I thought I at least gave you a couple of binomial distributions, but evidently I didn't. Dang old second, enter. Dang old 15. Second, delete. 1, second, delete, turn it off. 15, 12, 7, 5, and 12. I got 0.225. When is the week of finals? Somebody will miss that one. When is the last day of class? Only one possible answer there. This is a stupid question. This is the racist question. Oh, they did put in Mexican American. Okay. All right, now this one is not that difficult, but I'm going to show you how to do it. First of all, find the probability of exactly 8. So you look up 8. There it is right there. What is it? 0.121. That was hard. Find the probability of 8 or fewer. So what are you going to do? 8 or fewer. You're going to add up what? Or fewer. Or means what? Add, Hubert. Yes, that's right, class. Thank you for the interaction. Or, what would be easier than adding up all 8 of these? What would be easier? That's not rhetorical, I'm asking y'all. What would be easier than adding up 8 of these numbers? This is when I get depressed. Thank you. Adding up these numbers right here and subtracting them from 1. It's called the what, y'all? Starts with a C. Complement. I think y'all just try to make me mad. I think that's what it is. So add up those 4 right there and take them away from. So 0.54, 0.16 is 0.7, right? No, yeah. 0.07, excuse me. Y'all check me. 0.073. Y'all check me. I don't know what I'm talking about. And then subtract it from 1. What do you get? 0.927. Which probability is relevant for determining whether 8 jurors among 12 is unusually low? The result from part A or part B? This one in 15-part questions. Okay, 4 parts. Which probability is relevant? Now you got exactly 8 or 8 or less. Exactly 8 is 0.121. I would say less, 8 or less, wouldn't y'all? Because the chances of 8 exactly is going to be much more unusual than point. But that's common sense. But I'm not going to say I'm going to get it right. Not with this book. So that's why we're changing books. I would say 8 or fewer. Mark that one because I probably get that one wrong. Is 8 an unusually low number of Mexican Americans? Well, look at it. Is 8.121. How many? Where is it? There it is. How many cents is that? 12. So you tell me. What's the magic number that we match up unusual with? 5 cents, right? So is that above 5 cents? So that would be what? Normal, right? And what tells you to do that? Well, these questions right here tell you. See what it says? Greater than 5 cents, equal to 5 cents, or less than 5 cents, greater than 5 cents. So this tells you what to actually do. Compare your 12 cent to your 5 cent. Ours is normal because it's more than 5 cents. So you got to find that. Now, this guy that writes this book or writes these questions, he tries to do everything in the world on these questions to screw you up. So it screws me up sometimes. So you got to be careful. Is 8 an unusually low number? Is it unusual? No. So you got to pick the one that says no. All right. Now you got to match it up. Greater than 5 cents. So it's 8. You got to be careful on these. These two questions is the reason that we're changing books. Is because we do not like the way he words these questions. It's like he's trying to trick the students. What's the only possible answer? The only possible answer is that and Boy Scouts. No, I wasn't in the Boy Scouts. N, P, and X again. Y'all are so lucky I'm giving y'all this easy test. I think I need to go back and change it. I really think I do. So, I'll go back and change people I don't like. How about that? So 6.85 and 4. 6.85 and 4. 0.176. Is that what y'all got? Yes, Hubert. No, Hubert. Thank you for the interaction, class. All I asked you for is a simple yes or no. I can't hear you when you... I can't hear you. Enunciate. Dang old. How am I supposed to hear that? Okay, here's your Casey and what's her name? Tobias or whatever. Is this? Okay, don't name the TV show. A certain TV show recently had a share of 85, meaning that among TV sets, 85%, there's your P right there, were tuned to that show. So this must be a pretty good show. Alright? Assume that an advertiser wants to verify that 85%, blah, 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 begins with 8 households. So he's got 8 houses. Okay? So 8 is going to be your dang old what? N. Find the probability that all of the households are tuned to that TV show. So what would that be? Well, let's highlight the word all. So what is X going to be? No sneezing, please. Just me. I can only sneeze. So what is X? We're going to sit here till somebody answers it. I'm not answering it. Let's whisper so we can all straighten our ears. What is X? If the word says, if it says all. And you got 8 houses. Boy, y'all are on the ball. I ain't kidding you. Yes, you're right. Living in a box in the ditch. So take our handy dandy and second function and change this to 8. And is it 85%? That's nice. And change this to 8. 0.272. Find the probability that exactly 7 households are tuned into TV show. Exactly 7. So what would that be? NP what? I mean, that would be 8, 85, and what? 7. Oh, I should be ashamed of myself giving y'all this simple test. 0.385. Okay, I'm going to let y'all do C. I didn't do that. I don't know why it does that. An anti-police activist group calling itself Disarm NYPD is aiming to strip officers of their firearms and boot them from certain neighborhoods entirely. I'm not going to say a word.
They complain about police brutality and stuff. Maybe the police don't have to be. Maybe the police.
If they wouldn't resist arrest.
Or maybe if they weren't doing something stupid.
I agree with that 100%. It's kind of like I don't worry about people listening in on my phone conversations. Do you know why? Huh? I ain't got anything to hide. I don't think I'm going to be. Well, I am a terrorist because I'm a veteran and I'm from the South, so that means I'm a terrorist. And some people don't have any idea what I'm talking about, but anyway, the probability that at least 7 households are tuned. What are you going to do? You going to add up all 7? Or are you going to add up 7, 8, 9? Or what are you going to do? What does at least 7 mean? That's the lowest number. So you're going to add up what? 7 and 8. Okay, I'm sorry for that. I thought we had 9 houses. 7 and 8. So you're going to take 7. You got 7 right here. So, and is that 8 right there? Okay, so add those 2 together. What do you get? Point what? Thing 6, 5, 7. You enunciated that time. You didn't go. I know. That puberty thing, is that what it is? 0.657. Okay. Sleep. Okay, this is the question that if you get wrong, I probably won't hold it against you. I'll probably just give you the points because of the way they word it. If at least 7 households, that's this one right here, are tuned to the TV show, does it appear the 85% share value is wrong? What would you say? Okay, people, it's either yes or no. If it means that, see, I don't know what 85% share means. Does that mean that their number needs to be that our number needs to be above 85%, or does it mean that it needs to be below? I would say that it needs to be below 85%. So in that case, it is not wrong. Is that what you're trying to say? So you got to read it. It says, is the 85% value wrong? I mean, I'm not a TV person. I don't know what shares mean. So, a certain TV show recently had a share of 85%. 85, meaning that among the TV sets, 85% was tuned. Well, this says that at least 65% or 66% is 7 households. Mathematically, it doesn't match up. It's wrong, okay? Because 66 is not equal to 85, all right, mathematically. But if they're asking if the 65 is within the margin of 85, then yes, it would be yes. It's not wrong. But if it exceeds 65, then it isn't wrong. So I don't know what the answer is. If you want to know the truth about it, anybody want to just spit one out? Just say A, B, C, or D, somebody. Vanna, say one. Okay, Vanna's over there now. All right. That's all right. At least you said something. Next question. Mark that one. We probably got that one wrong, too. We didn't get the numbers right. And that's all I care about is these numbers. Because I have no earthly idea what this means. I'm just going to be honest with you. I'm not going to lie to you. There we go. We got a probability distribution here. All right, now I'm going to let y'all do this because you want the mean and standard deviation. So get to it. That's where you got to dang old add them all up. Do your columns. I'll copy them and put them in the Excel spreadsheet so y'all can watch it. I'll move it. I'm trying to get it over where y'all can. There we go. Find the mean and the standard deviation. And go ahead and draw your curve too, just for practice. Sorry. Okay, what's the first thing we need to find the mean? X times what? Good job. So equals this guy. I'll do the first one for you. Times this guy, but the answer's 0. And we're going to copy that down. And then what do we do with that after we do it? What do we do with all those numbers? Add them up. And there's your mean. Now, what do we need to get the other stuff? Well, we got to have x what? X squared. And you can do that in your head, 0, 1, 4, 9, 16, 25. Or you can just do it in your spreadsheet. And then the last row is x squared times what? X squared times p of x. Make sure you pick the right column if you're using this, because sometimes, or when you're using your calculator, because your eyes might pick up the wrong number out of another column. So make sure you do x squared times p of x. Again, I'll do the first one for you. That would be 0. And then what do we do with those numbers? Add them up. And standard deviation is equal to this number minus parentheses this number, what? Squared, Hubert. That's right, class. And there's your standard deviation. Now, to do your normal distribution, oh yeah, you got to take the square root. I'm sorry, the variance. Let me put the variance right here. Thank you. I forget that. Where is my... variance, and then if we want the standard deviation, what do you do to the variance? Raise it to the 0.5 power or take the square root. So that's equal to this guy raised to the 0.5 power. There you go. Thank you. And now you do your normal distribution, which is equal to the mean, and then equals this plus that equals this plus that equals this minus that and equals this minus that. So what's normal with this information? What's normal? 2.3 to what? 5.8 or 6, yeah. Question. I don't know what they're asking. Let's see what they're asking. They want the mean and standard deviation. What do they say? 4 point, what we got to round to, because I'll put in the wrong thing if I don't. Round to 1 decimal place. So that would be 4.1 and 0.9. 4.1 and 0.9. Next question. No, I was hoping that one wasn't on there. When someone buys a ticket for an airline flight, there's a 0.09 probability that the person will not show up. A certain jet can seat 12 passengers. Is it wise to book 14 passengers for a flight? So we got to find, is this where we add 14 and 15 up or something like that? 13 and 14, ain't that what we did? I can't remember because we, yes, and do 13 and 14, and that's what we did. So just do it like that. I don't know why they did it like that, but that's, so 14 is in, and just use 13 for X and 14 for X and add them together. In other words, you got to do two of them. But your P is what? The probability of somebody showing up, right? So that's going to be 0.9018. Somebody check me. Dang old probability. 0.9018. So I'll go ahead and put one of them in. Second function, enter. 14. 0.90, insert 18, and 9018, because this is the probability that the person will not show up. 0.9018 and 14 or 13. So Stowe, where you buy your bread, alpha, and we'll call that the first number, so we'll call it F. And then second function, enter. Second function, enter. And change that to 14. I get that plus alpha, what do we call it? F. Enter. I get 0.59. What does it say round to? Round to 4 decimal places. 5939. 5939. Now I got a question. If you were the person at the gate, you know, when you go to the that place that has airplanes, what's it called? The airport. When you go to the airport, there's a woman, or usually, I'm sorry, there's an attendant there at the gate. You know, where you go and walk over that catwalk to the plane. There's a person there. Would you want to be that person with a 60% chance that 13th or 14th person shows up? Then is it wise to book with 60% chance that they're going to show up? I wouldn't, but I don't know what their answer is. I know that mathematically the 0.5939, I know that's right, but I don't think it's wise to make that. I don't think it's wise with a 60% chance that they're going to show up. So, okay, let's read the question. Is it wise? Is it not wise? Oh, it is. I'm sorry. It is not wise. That's one I'm going to go with. A or what? D. Because the probability that there are not enough seats on the plane is point what? 69 or 0.59. That's what I would say. I would say is not. So overbooking is not. Okay, I think it's A. I think. It says so overbooking is not an unlikely event. Not an unlikely event means what? Likely. So with 0.6, is somebody going to show up? Is that 13th or 14th person going to show up at 60% chance? Yeah. So I think it's this one, A. I done forgot my number. I got to go back. 0.5939. Okay, find your mean and standard deviation. Let me go ahead and get it in the Excel spreadsheet so y'all can see it and you won't have to. I wonder if I can just put it right here. I don't know if it's going to match up or not. Yep, I'm done. Y'all done? Oh, I'm sorry. I got to punch it in the calculator. I'm being a smart aleck. Can y'all see it? Yeah, I can see it. That's the good thing about the Excel spreadsheet. You just punch it in. If it's got the same numbers, the same number of data, which it did, if you do it right, you ain't got to do anything else. So did y'all come out with the same thing? Or y'all finished yet? I'll wait. Go ahead and help roll time there. Bailey, Bolt, Clayton, Cowart, Dutchke's here, Escobar, Farr, Freeman, Hammett, Harris, Harvey, Hayes, Johnson, Mullins, Murray's here, Newton, Poor, Perdesi. Did you get that thing fixed, Mr. Perdesi? What was the problem? Did they just, okay. Well, you need to see me after class. I need to check with you on some dates. Robinson, all three of them are here. No, got one missing. Little Robinson. Mahogany's not here. Right? I don't see her. Miss Scarborough is here. Schuler. Simpkins. I saw Dennis. I thought I saw Dennis. Oh, he's left. That is, yeah, that's here. Dennis is here. Smallwood. Not here. Both, no. One Vaughn is here. The other one's not. Williams and Wood. Okay, bureaucracy's done. Alright. Is that what y'all got? Okay, we're going to move on. So, mean is what we got to round to. Dang old. Round to one decimal place. So that would be 3.4 and 1.0. God, that was nice. 3.4, and 1.0. Next question. How is each unit test counted? All three forms. What I do with them? I'm thinking C. It's B. Will Hubert's final exam be online? What the heck is this? Oh, another binomial distribution. I'm sorry. Ted is not particularly creative. Ted sucks. He uses a pickup. Oh God. He uses a pickup line. If I could rearrange the alphabet, I'd put you and I together. The random variable X is the number of girls Ted approaches before encountering a slap. No, before encountering one who reacts positively. Determine whether the table describes a probability distribution, so that means you got to check these to make sure that it equals what? I'm sorry. Hold on. Vanna's not doing her job this morning. I just hadn't got to get her to the remote. Here you go. All right. What do you do to check to see if it's a binomial distribution? Add all the ones on the right, and all of them supposed to be between 0 and 1. They all are between 0 and 1, but you need to add them up to check. 3 and 2 is 5, or 3 and 2 is 6, 7. I don't know. You're going to have to add them up and see. If they don't add up, then you don't have to do the problem. I don't think they're going to give you one of those, but we'll go ahead and copy, pull up our handy dandy Excel spreadsheet, and dang old paste. And we got to change. Oh, they didn't put 0. Did they not put 0 in this one? Okay, that's fine. No, they didn't. Okay, so I got to delete this one. So let's check and see if this is it a probability distribution. I can't believe I gave y'all this easy of a test. If y'all fail this test, do not tell anybody, okay? Just keep it to yourself. What's the only answer? When does the homework terminate? It's supposed to terminate midnight before the test, but I don't do that. I need to take that question out. Oh my God, not this one again. All right. 12 households, 20%, none. So what would that be? Be 12, 20, and what? 0. So second function, enter. Second function, enter. 12.2000. I'm just putting 4 digits in case we ever have a 4-digit or what again. And 0. 0.06, round to 3 decimal places, 0.069. At least 1. So that means 1 or what? More. So I'm going to take 0.069 away from what? 1. And that's going to give me 0.931. Somebody help me out. Okay. At most 1. So what does that mean? You take 0 and 1 and do what? Add them together. So we got 0 right there. So we got to do 1. So take your handy dandy calculator. Second entry. And put a 1 right here. And enter. And you're going to add that to 0.069. I got 0.275. So that's 28%. Find the probability that at most one household is. So we got 28%. What did they say? 20%. We exceed the 20%. So whatever that means, I have no idea if we're supposed to exceed or be under, because I don't know what it means. Well, if that's true, then it'd be 28 minus 20 over new minus old over old. So that'd be 28 over 20 divided by 20. So if somebody do that, I'll do it. 28 minus 20, enter, divided by 20. I get 0.4, which is 40 cents. It's greater than, but I don't know what the answer is because I don't understand what a share is. I don't know, does that mean that we got to exceed 20% or we don't? I don't know. So I can tell you that it's greater than 0.05. I'm just going to say yes. I don't know the answer to that. I'm not going to spend time on that anyway. I don't care if you get it wrong, just let me know. But you got to let me know. 12 peas are generated from parents having the green-yellow pair of genes of peas. So there is a 0.75 probability that an individual pea will have a green pod. Find the probability that among the 12 offspring peas, no more than one has a green pod. So what's that? There's your one right there. So 12.75 and what? Now it says no more than one. 0 and 1. So you got to do 12.75 0, 12.75 and 1. So do that. Second function, enter. Second function, enter. Second function, enter. Second function, enter. 12.7500 and 1. And well, we'll do 0 first. That's a small number. 0.000000. It's going to have 7 zeros in it, right? I think we can pretty much say that's 0. Now, second function, enter. Thing 01. That's 0 with 5 zeros and 6 zeros is pretty much what? 0. 0. I better put 0, 0, 0. I better put 0.00, not mark it wrong. I don't know what this thing's going to do. Okay. Is it unusual? Well, you got 0 cents. You got to have 5 cents. So what's the answer? It's unusual. So why? Because of this current is very what? Very small. Assume the probability of a child, of a girl, child being probability of find the mean. Okay, let's find the mean. Let's take this, copy it. Then go take our Excel spreadsheet. Then go put it in. Did it copy everything correctly? Let me make sure. Okay. No, it jumped to 5. That's what I'm saying. 0, 1, 2, 3. So I need to take it off. Y'all check my numbers now. Make sure that they're still decent. Okay. See what y'all get when y'all do y'all's. Y'all get those numbers? .4 and .9. Mean is 1.4 and the standard deviation is 0.9. I'm going to leave that up there for a second. Is it unusual for a family with 3 children to have only girls? Well, 3 girls is, let's see, this is in terms of girls, right? Yeah. 3 girls is how many cents? 0.098. What is that? 10 cents, Hubert. That's right, class. 10 cents. So 10 cents is what? Then 5 cents. Greater. So what does that mean? It is not unusual, which means that it's normal. So is it unusual? No. Because it's greater than what? A nickel. Your dime right here, I'm sorry, the 3 is 0.098. Well, that's a dime. That's 9 cents. Actually, it's 10 cents. And that's greater than 5 cents. So if it's greater than 5 cents, then that means it's normal. Okay? So we answered those questions. Next. Why does Hubert not entertain extra points, extra credit, and dropping any grades the last week of the semester? Why? Because he's awarded extra points like these on the test, and he drops the lowest 2 on each unit. And submit test. And we probably got wrong the questions that I predicted we would get wrong. What'd I make? Dang old 95. Dang old, I bet you $1. These 2 right here. Well, did we have 3 of those questions? Yep. I have no idea what they're talking about. And I guess I need to sit down and read it. I don't know. But it says yes because 7 households tune to. Okay, well that's great. There's a 66% chance. I'm not going to worry about it. Let's see, what else did I miss? What? Same one. Well, I'm not going to worry about it. Like I say, I'll count yours right. Oh, did we not? Oh, poo. You got to be kidding me. Every one that we did, because it's the 3 digits. That's the 3 digits right here. That's why they want it to 2 here. Okay. I would count all 3 of those right. So, I'm not going to worry about that, all right? All right. So, y'all good for chapter 5? All righty. Y'all have a good day. Somebody hit my button for me.